Morning, students. Today we're going to look at section 6.2, which is volumes by known cross sections today. I'm going to share my screen with you again so you can see the presentation. All right. And as always, I'm posting the notes with the solutions on Canvas. So here I'm going to try to explain this. So just two examples today. We're going to calculate the volume of a known cross section. The base shape here is a parabola given by the equation x equals 4 minus y squared. It's also bounded by the y-axis. So we're talking about, let me turn my ink on here. So we're talking about this is the y-axis, and then here's our parabola. So this shaded region is the base of our shape. And then what we're going to do now is we're going to have cross sections that are emanating from the x-axis, and they're going to be perpendicular to the x-axis, and they are semicircles. So we've kind of got a semicircle, if you will, coming out of each of these. And as we get closer to the y-axis, they're going to get bigger. And as we're closer down here, they're going to be smaller. So our formula is volume equals integral from A to B of our area function dx, or ds in this case. It's going to be dx in this problem, but in general it's ds. So the first thing we want to do is we need to figure out what our area function is. Well, the area function has to do with the known cross sections, which in this case are semicircles. Well, a semicircle is half of a circle, so the area formula is going to be 1/2 pi r squared. Now, we can't just plug that in because, first of all, we're going to integrate this with respect to the x-axis because it's perpendicular to the x-axis. And here we have r. So kind of the toughest part of this is we've got to now write our equation in terms of x if we can to figure out what the radius would be. So I'm trying to find the distance, if you will, from here to here. In other words, the x-axis up to that top curve. So if we solve x equals 4 minus y squared for y, it'll turn out that you'll find that y is equal to plus or minus the square root of 4 minus x. Now we don't need to worry about the plus or minus. The plus is just the top half of the curve. The minus is the bottom half of the curve. We only need the top half. So our radius here is going to be defined as the square root of 4 minus x. Okay, so to find our final answer here, area, which is volume, sorry, is going to be equal integral. Where are we starting? Well, we're starting at 0. Where are we ending? Well, we're ending at 4, so it's going to be 0 to 4 of our area function, which is going to be 1/2 times pi times whatever our radius is, which is 4 minus x quantity squared dx. So now I've made all the conversions that I need. You can clean this up a little bit, so I'm going to end up with a pi over 2, which is a constant on the outside. We're still integrating from 0 to 4. When we square the square root, we're going to get 4 minus x dx. And then I'll let you do the integral of this. The final answer turns out to be 4 pi, exactly. So that's example number 1. Example number 2, I'm going to not do as much work. I'm going to encourage you to get your calculator out and actually do the work on this one. I'm going to give you the highlights, and I would encourage you to go through and see that you agree with me. So we're going to calculate the volume of a solid obtained with a base formed by these two curves. Now, I'm just going to tell you right now, these curves are kind of interesting. Make sure you're in radian mode. And I want to draw the curves for you, but I'm not going to. You need to do this with your graphing calculator. You'll need to adjust the window and all those things. You'll need to figure out, and I'm just going to tell you the formula again, which is volume equals the integral from A to B of our area function with respect to S ds. Now in this case here, we know that our areas are going to be squares. So the area function is just the length of a side of a square squared. But remember, we need to put that in terms of x somehow. So That's where this picture comes into play. And I'm not going to draw it for you, but I'm just going to tell you this. You need to do the top curve minus the bottom curve and then squared. That's going to be the area function that we're going to use here. And I'm just going to tell you now that the top curve turns out to be y sub 1. The bottom curve turns out to be y sub 2. You should verify that with your calculator. So the volume is going to be equal to, and I'm going to give you approximate values for A and B. A is approximately -2, -2.140. Get rid of my decimal there. And B is approximately 4.003. That's a 0. And now we're going to integrate y sub 1 minus y sub 2 squared dx, because we're going to do this along the x-axis. And your final answer here is going to be 4,038.460. That's approximate, obviously. I should maybe put an equal sign. I should probably make this approximately equal to. Again, I would highly encourage you to use your graphing calculator to verify that solution. So hopefully I didn't make a mistake. We are going to stop there. Have a good day.